Welcome everyone to our workshop on reinventing the telco consumer experience. It is now the top of the hour. We'll give it a couple minutes for more participants to file in. In the meantime, feel free to be patient with us. Again, we'll be starting in a minute or two. Thanks for joining. Hello, everyone. Thanks again for joining our workshop today. We will get kicked off in about a minute, just waiting for some more folks to file in here. All right, everyone, we will get started. Thanks for joining our workshop today on reinventing the telco consumer experience with data and AI. We are very excited to have you join us today. Telco is a huge area where we're seeing a lot of growth among our customer base, and we're excited to share with you both kind of what we're seeing, but also give you some assets that can be used for some of the use cases that you might be working on within your own companies. Before we get started today, couple housekeeping items. Your connection will be muted for the duration of our presentation today. However, please feel free to submit questions in the Q&A panel that you can see here through the Zoom interface. Questions will be answered after the demo session at the end of the presentation. We've allotted a big chunk of time to handle your questions. We love your questions, so please don't be bashful. Please give them to us. And last but certainly not least, the session will be recorded and available as requested after our presentation. To kick off our agenda today, some brief introductions for myself and our other speaker. I'll be talking a little bit about how Databricks is helping communication service providers from use cases spanning the world of network analytics to Customer 360. My colleague will be doing a demo of a few different assets that we have, again, that we'll make available to you after today's presentation that are focused on survival analysis as well as customer lifetime value. And of course, we have plenty of time at the end for questions and answers. My name is Steve Sobel. I'm our global industry leader for communications, media, and entertainment. I work with all of our customers globally to understand the patterns and practices of how they're using Databricks, but also where Databricks fits within their data estate. I'm joined today by Dan Morris, who is our technical leader for communications, media, and entertainment. Dan recently joined us after 15 years in the media industry, working on a number of lifecycle use cases for consumer that we'll be showcasing today. So before we kind of dive into what we're seeing in the communication service provider space, for those of you who might not be familiar with Databricks, we basically are a platform that brings together the worlds of data engineering, data science, and business analysts to really drive more innovation, drive kind of more and bigger business results as it pertains to the worlds of big data, machine learning, and AI. We have the great fortune of working with over 7,000 customers globally, including many in the telecommunications and communication service provider space. So customers like T-Mobile, like TalkTalk, like Comcast, and a number of other customers, really helping them, whether it's consumer experience, whether it's around asset management, how they manage their fleet, how they manage their network to drive a more performant network. Again, really helping to drive more innovation, more results when it comes to all things big data, AI, and ML. We are the original creators, our 6 founders of Databricks. We're the 6 founders of Apache Spark, which is the big data processing engine of choice for many enterprises around the globe. We also have been the lead contributors to a couple of other open source initiatives in Delta Lake, which is a open source initiative to drive more performance and reliability around the modern data lake, as well as MLflow, which is a machine learning lifecycle platform. We have, again, worked with customers of all shapes and sizes. I know I mentioned a few specifically in the communication service provider space, but companies large and small, really helping them optimize the kind of performance of their big data initiatives, really helping them apply machine learning and AI to these big data initiatives. And whether it's use cases of how we're helping to decode the genome in the health and life care space, or how we're helping to help banks, increase their amount of fidelity they do around projects like fraud detection, or the media space, helping to drive kind of real-time personalization engines for direct-to-consumer services like Showtime. Our use cases there's thousands of different use cases that we see on our platform. And ultimately, we are a platform built on use cases, helping customers really derive more business value from their big data initiatives. Specifically in the communication service provider space, we see a number of trends. This is communications has really moved from being a utility to really focusing on service, and really enabling a lot of innovation that we see. We're all in this time where we're all working from home now, and really what communication service providers are doing is, whether it's broadband service, whether it is wireless wireline service, it's really the backbone for how companies have been able to really kind of respond to this odd time that we find ourselves in. Really, a lot of the innovation that communication service providers are driving are around a few different common areas. Of course, we hear about 5G constantly, either customers that are launching 5G networks or getting ready to launch 5G networks. We see customers in the communication service provider space that are looking to get into AI, leveraging AI use cases in terms of how do they automate their services, how do they get ahead of and kind of drive more accuracy around predictive maintenance use cases like that. Of course, given that many in the CSP space are network providers, IoT, machine to machine, and all of these connected devices that are coming online, and how can telcos, communication service providers monetize these services. And you're also seeing more and more kind of competition and new models. Of course, the move from triple play to quad play to quint play is nothing new, but many of the telcos that we're working with are looking at new partnerships and trying to figure out how do they take the relationships they have with their end users and drive new and better monetization strategies. In terms of all of this kind of change that's going on, whether it's 5G or responding to IoT, many of the telcos that we work with are very much focused on the same kinds of areas in terms of how they deliver their services. It's no surprise to many of you, communication service providers over time have generally had, have not been known for providing, best in class service. As an industry, there's been challenges with, customer satisfaction and NPS scores. And really, as there's been more competition coming online, a big focus has been around improving the consumer experience, reducing churn, and really, moving from, being a utility to being a high valued partner in both a B2C and a B2B scenario. Reducing the cost to serve and operate, that of course is very, a focal point. We're of course hearing many customers that are either on-prem that are looking to cloud because of the cost savings they're having, or maybe they're already in the cloud, they're looking to drive cost out and or really drive more efficiency around some of the workloads that they're having. Margin, this is something that, whether your business is wireless, wireline, satellite, being in the telco equipment space, this of course is kind of a big focus area. I mentioned this a minute ago, but finding new revenue sources via partnerships or getting into new lines of business, whether it be security, whether it be broadband, to drive top line growth, a big area of focus. And then last but not least, really scale is a huge consideration for every single operator, whether it is preparing for 5G, whether it's preparing for IoT, whether it is, really ensuring that your pipelines are in a place that they can be ready for either real-time or near real-time use cases. huge focus for everything that we're seeing in the space. Um, in terms of the focus of what communication service providers are doing in that context of, of course, we know we need to mitigate churn, manage margin, be ready to kind of have highly scaled services. We see a few different kind of repeated patterns for the types of use cases that we're seeing in the space. Kind of personalization, particularly omni-channel personalization, and not just optimizing for a retail or an e-commerce or an online channel. We're seeing more CSPs really look at the consumer experience more holistically. How do I kind of have a one-to-one conversation with my end consumers, not have a disjointed experience? This also applies though for the employee experience. How do I give my my team the tools, the data that they need to drive innovation faster, and really provide a best-in-class experience for employees as well. Monetization strategy, whether it's, how do I better monetize my consumers? How do I better monetize my network? How do I better monetize, the services within my portfolio? Of course, this is top of mind and really an area where big data and machine learning can help. And then last but not least, IT can no longer be the bottleneck, can no longer be the place where, the kind of land of no. IT has to be ahead of the business to really drive agility, have the best-in-class tool set to deliver personalization, monetization, and agility for the business. While all of that sounds lovely, the world of telcos, communication service providers is very complex. The amount of data, the scale of data, the inability to get to and join batch and streaming workloads. This is really hard. So while there's a major promise, everyone talks about infusing machine learning and AI into their business. But what we find is that a lot of the data for communication service providers often hits the floor, meaning we don't know the lifetime value of our customer because all of that data that we would need is not in one place that we can actually analyze it. We can apply machine learning to it. Use cases like network performance, looking at PCMD or CDR or LSR data sets, really hard, really complex, particularly when you're looking at the scale and the velocity of the streaming pipelines that you would need to get to some of these use cases. Leveraging AI and ML in terms of, where is my fleet? How do I do fleet routing? How do I get ahead of any predictive maintenance issues? These are very challenging from what we see in this space. And ultimately, you need a platform to unlock the data to help your organizations go faster. Databricks, we are that platform. Really, the headline of what we do is we have the ability to take all of your data, make it ready for machine learning and AI, and do it really fast. As the inventors of Apache Spark, we are kind of the processing engine, the high performance engine that many enterprises around the globe are using. And whether your data is, batch or streaming, structured, unstructured, NLP, or the ability to do image processing, these are all things that we do inherently on our platform. We work within a customer's AWS or Azure environment. So essentially, if you're landing your data in S3 on AWS or within blob storage on Azure, we basically, our Delta Lake and our Apache Spark technology allows you to act as an abstraction layer, take this data, make it ready, refine it for either data science use cases or BI use cases, and do it in a fast and performant way. So things like the ability to join batch and streaming for CDR analysis, or understanding PCMD use cases, or understanding CLV use cases. Again, it's that ability to have everything in one place and not have to move your data from already where it's landing within AWS or Azure, but basically have that layer with which you can go faster around these BI and machine learning use cases. We are built on use cases. While there's thousands of different use cases that we see on our platform, we tend to see a few different areas of investment within the communication service provider space. First, and this is really what we're going to focus on today, is all things consumer experience. Consumer experience was not a huge investment for the telco industry if you roll back 5-10 years, but now this is becoming the focal point, and kind of everyone wants to be that differentiated service provider. So things like next best action, next best offer, putting intelligence into your chatbots to be able to automate some of your call center or self-assisted channels, things like customer 360, customer lifetime value. These are all use cases that CSPs are building with us And again, leveraging, kind of their cloud investment in AWS and Azure, so that they're not moving it. Again, we're just kind of that more performant engine that involves AI and ML to get to some of these business impacting use cases. Data and network optimization. We see many telcos that are focusing on, moving from on-prem Hadoop environments where they're incurring a significant amount of cost to leveraging Databricks as the kind of platform where they can do, PCMD, CDR, LSR pipelines, where they're able to do roaming analysis. They're able to do quality of service, quality of experience use cases. Again, this is when we talk about high scale, real-time use cases, this is really an area where we shine, and we have a number of customers that are in the telco space that are building these pipelines with us. IoT and machine to machine, another area where, could be predictive predictive maintenance use cases, or routing for fleet, fleet management use cases, understanding capacity planning for kind of your field teams. A big area where, we're kind of seeing, consumer experience and data optimization network be kind of where you start, but ultimately in the continuum of crawl, walk, run, IoT and kind of connected devices. This is an area where we're starting to see customers dip their toe in the water around kind of building these pipelines out. And then last but certainly not least, security and compliance. Of course, this is a huge area of focus for every single enterprise across the globe. Telcos are no different here, whether it is kind of compliance use cases like GDPR, or whether it's more security-based use cases of brute force attack, kind of bot detection for either your commerce channels or your advertising channels. Again, an area where we see significant amounts of investment. One thing, and this is a segue in what we're about to show you for the rest of the time, which is going to be kind of a hands-on demo and notebooks that we have available. But as a company, for Databricks, we are, of course, we kind of are cloud only. We don't have a on-prem version of Databricks. And we basically exist to kind of unify data across all of these different silos, and again, take all sorts of different kinds of data to help you drive business results of this. But we often see, very common challenges for our customers that are looking to get to some of the use cases that I just spoke to. Some of it, it might be you are just kind of in early stages of developing your data science team. Maybe you do not have domain expertise, people who are deep on OSS, BSS stack, or kind of understand kind of the backend architecture of a telco. And a lot of times, we're dealing with, executives that are looking for recipes. They're looking for quick wins. They love that we're a platform, but, platforms have a double-edged sword of you can build anything, but, are looking for kind of key ways that they can get started faster around common use cases. And what we're going to show shortly is a new program that we've started called Solution Accelerators. Essentially, we are building out tools in the form of notebooks, of blogs, of architectures, technical assets to help you get moving faster around what we view as, and what we see as common use cases. So again, these are kind of, I would call them either 50% solutions. They get you most of the way there. So the research, the model building that you would generally have to do to get to some of these high business value use cases, we do that for you. It's as easy as kind of clicking, importing a notebook into your environment. Of course, you would need to do some of the setup of getting your pipeline so you can get to these use cases. But ultimately, our goal here is to help you get started faster. If you're not a customer, maybe it's a great way for you to start a POC. Or if you are a customer, maybe it's a great way for you to add a new use case that you may have on your roadmap but just haven't gotten to. Or it could be an area where you have this use case in production already, and this could be an alternative means for you kind of evaluating, do you have kind of the right model, the right thinking in terms of building out this use case over time. What we're going to be showing you today are two different accelerators that we have that are focused on the telecommunications industry. One is around customer survivorship and churn. The other one is around customer lifetime value. Have no fear. If you're interested in either one of these notebooks at the end of today's session, we'll send out the links so that you can kind of play around and look at these within your own environment. And what I'll say also is we are early in the process of building out this industry solution accelerator program. So a quarter from now, a couple quarters from now, we'll continually be building more based on what we hear as customer demand. So we'd love your continued feedback on what other use cases we should be building towards that could help you in terms of providing more value for your journey with Databricks or just in the big data space in general. So I am excited to turn this over to our technical leader, Dan Morris, who he's going to walk through the assets that we have available. And again, we'll walk through these assets. They'll be available after our session today. And as you have questions about these notebooks, absolutely feel free to drop your questions in the Q&A panel here, and we will get your questions answered once we go through the demo here. So Dan, over to you. Take it away.
Thanks, Steve. So 1 second, I'll bring up my screen. Cool, so everyone can see my screen, right? So as Steve mentioned, Dan Morris, I'm the technical lead for communications, media, entertainment. And as Steve went into, within the telecom industry, it's really like vitally important to really be able to effectively manage your customer relationships, whether that's being able to lengthen the amount of time that they're with you, or even being able to use kind of their value, their LTV in different capacities. And so what we have found is talking with customers really across different industries. One of the very commonly used techniques is survival analysis. And so what we're going to do today is we're actually going to walk through an end-to-end example of survival analysis. And at the end of that, what we're going to do is we'll actually use it as like an input for a lifetime value application. We'll get into the details of this later on, but just to kind of give a glimpse of where we're going into. And so within the realm of survival analysis, what we'll do is we'll actually cover 3 specific techniques: Kaplan-Meier, Cox proportional hazards, and accelerated failure time. And one extra thing that I just want to highlight, my intent for this is very much to kind of arm you with the information that you need to kind of jumpstart your own effort. So I will be walking through all the code and the data, but I'll also be layering in a little bit of the theory and the math behind it, just to kind of establish that intuition. So now diving into the data. The data set that we're going to use it actually comes from IBM, and it represents a fictitious telco company. And I like this data set for really 3 reasons. One, obviously telco is very relevant for this crowd. 2, it's fairly simple, so lets you really kind of focus on the techniques. And 3, there's actually a very commonly used data set across the web specific to this use case. So as you dive in, if you want to be able to get additional perspectives and just be able to kind of explore it, you have that readily available. And so diving into the data, what you'll see is there's basically 1 row of data for every single customer. And for that, each customer, you then have demographic information, so like gender, dependents, et cetera. You have information about the service that they have. So do they have DSL or fiber optic? Do they stream TV and movies, et cetera? And then, I know like I subscribe to Verizon, paperless billing's popular thing. So has information about their billing patterns, so paperless billing, payment method, et cetera. And then the two fields that are actually super important to highlight here are churn and tenure. So churn, we're not going to actually use that in the traditional sense of predicting whether or not a subscriber will churn. We're actually going to use that as a means to getting to duration, because at the heart of survival analysis is really understanding what the amount of time it's going to take for an event of interest to occur. And so you have the churn, and then lastly, you have tenure. So what tenure represents in the case that a subscriber has churned, it represents the amount of time that the subscriber was with you before they churned. And in the event that the subscriber is still with the company, it represents the amount of time they've been with you to date. And that's actually a super important nuance, which we'll get into rather soon. And then one last update is I did make a couple of filters to this data set just to keep it very focused. And so within the original data set, internet service, you have DSL, fiber optic, and no internet. I've actually filtered out the no internet users. And similarly on contract, there's month to month, 1 year, 2 year. I actually think month to month is a really fascinating kind of cohort to dive into, because you it really speaks to how you have to kind of manage it, because you always have that decision to kind of cut your service. So again, it's filtered down there, but the techniques apply in either way. And then before we dive into the actual techniques, I will also highlight, as Steve mentioned, all these notebooks will be made available. You will see that what we're doing here is we're bringing in the data, we're downloading it to our driver, bringing it into DBFS or Databricks, and then we're working with it. So again, all of this will be made available. And so just as a quick overview of what is survival analysis. So as I mentioned, it's very much used to study duration, right? So what is the amount of time it's going to take for an event of interest to occur? And this actually originated to study mortality. And then shortly after went into like financial, but more recently and more relevant, it's really used across all different industries, right? So within telecom, for example, customer retention, your event of interest is whether or not I'm going to churn. Hardware failures, if you think about all the investment in 5G, you need to have a really good understanding of when your different components are going to fail so that you can manage that. And similarly, device upgrades and data plan upgrades, you have these specific points in time where a consumer is proactively going to change their service. And that presents a good opportunity for you to kind of upsell or cross-sell them. And so understanding when those times are going to come so you can kind of influence their decision is super important. And you may ask, why do we need another technique? On the surface, it looks like duration is a continuous variable. Can't we just use like linear regression? And the answer is no. It really comes down to measuring duration is actually pretty hard. And the reason for that is that if we scroll back down to here, we see these users that have churned, right? So I scroll back, they've been with me 2 months, we're good, no problem. But this user who has not churned, they've been with me 22 months, but the fact is they could be with me 23 months, 30 months, 50 months. We don't really know. And that goes into this idea that it's right censored. We don't really know when it's going to end. And while you might be inclined to sort of just take averages, what you would end up doing is actually underestimating the length of survival. And so that's where the techniques such as Kaplan-Meier, Cox proportional hazards, et cetera, come into play. So now moving along to Kaplan-Meier. So this is the first of the 3 survival techniques that we're going to review. What you'll see here is a plot of a survival curve for the entire population for the data set that we just viewed. And the way you read this is, if you scroll down here, you'll see 34. The probability of surviving past 34 months, because our data is based on months, the probability of surviving past 34 months is 50%. And this is super powerful because now you have a really, really good understanding of what the duration is going to be at different points in time with conditionals added in. And the package that we're using for this is referred to as Lifelines, which makes it actually very, very easy to use. You'll see it actually is very similar to scikit-learn. You basically just need to specify 2 things in particular. You need to tell it what column are you using for duration. So in our case, it's tenure. And what column are you using for the event of interest that you're observing, which in our case is churn. And so what's really cool is that in addition to viewing at a population level, you might want to look at it on like a covariate level, right? You want to understand how each individual variable is kind of influencing that level of survival. And so if we scroll down to internet service, for example, this is actually this is a really good example because it's very much what you want to see when you're looking at this type of plot. What you want to see is some sort of divergence between group 1 and group 2, because that means that there's something causal or predictive. There's something there that helps separate the two that will lead to the duration being different for group 1 versus group 2. But of course, that's not always the case. So if we scroll up to gender, for example, you will see that the lines are actually very, very similar. And that's where a test that's referred to as a log rank test comes into play. And what the log rank test is, when you come across a situation like this, you want to test what a null hypothesis that are these two groups statistically equivalent? And the way you would test that is with a log rank test, which is a chi-square test. You basically are just looking at the p-value. Is it above or below 0.05? In our case, it's way above that. And so we cannot reject the null hypothesis that these two groups are statistically equivalent. And I think what's really interesting about this is, while, from a predictive matter, this might mean, this attribute's not really going to deliver you a lot of value, but from an inference perspective, imagine that as a telco, you recently provided users with access, or customers with access to a streaming service, and you want to understand what the impact of that is on retention. And what this would tell you is it's actually not really making an impact, but we have all these costs. And so that can go into kind of like a business case of why maybe you should take away the service. Or flipping that around a little bit, maybe you're looking at throttling. And this shows that it's not making an impact on retention, so maybe it's not so bad. And while there's obviously tons of factors that go into those types of decisions, hopefully that kind of just illustrates the way you can use this from an inference perspective. And the last bit that I'll show you here is that what you'll see, we'll actually come back to this a little bit, but you'll see that for some of these variables, the lines actually cross. And that's actually an important red flag that you can catch early on so that you can accommodate. But again, I'll come back to that in a little bit. And so that covers the Kaplan-Meier. And you can use this, you can output your data, you can use it in the applications that I'll show you in a little bit. It's very simple to kind of plug in. But you might be asking, how do I look at multiple variables, right? How do I take multiple variables into account? And that's something very important to highlight when it comes to Kaplan-Meier, is that it's very much for univariate analysis. It's for understanding one variable at a time. When you want to understand the effect of multiple variables, that's where you then need to switch over to a technique such as Cox proportional hazards. And so with Cox proportional hazards, you still have the capability to measure the same type of plot that we were just looking at, but the way you do so is a little bit different mathematically. And so it's very similar. We'll still walk through the code, but just to kind of explain some of the math to establish the intuition, what you're really measuring when you're working with Cox proportional hazards is what's referred to a hazard ratio. And what the hazard ratio is, you're basically saying, what is the change in risk that I should expect at time t, given some context, right? So at month 6, given that I have DSL, I have dependence, and paperless billing, what is that hazard that we should expect at month 6, given that I've also been around for 5 months? And the way this is calculated is that it is a function of two things, baseline hazard and proportional hazard. What baseline hazard is, if we go back to the data, the baseline hazard is saying, for all of these variables, let's pick a value. So device protection, no. Tech support, no. Paperless billing, yes. Pick a value, whatever it is, let's draw a line in the sand and treat that as kind of our baseline. And then you have the proportional hazard. And the proportional hazard is saying, we have this baseline, but what if we change one of the values? So what if instead of DSL, I'm fiber optic, and instead of having dependence, I don't have dependence? Now, what is that change in the hazard ratio and hazard ratio referring to churn? What is that change in the hazard ratio that I can expect given that information? And we'll go into more detail in the actual example, but one of the really important things to highlight here, and it's actually kind of subtle, is that the baseline hazard is a function of time, which is the t, whereas the proportional hazard is not. And that it actually goes into being what's referred to as a semi-parametric model, because you're specifying the form or the distribution that the proportional hazard is taking, whereas the baseline hazard, you're not. But it's very, very important because it actually is the kind of underpinnings of what the core assumption of the proportional hazard assumption is. And so if you look here, what you want to see, again, there'll be more examples below, but when you're looking at this type of information and you plot two different groups, what you want to see is for these groups to be parallel, right? So this shows that there's proportion. So irrespective of where in time we are, it's always the same proportion, whereas this is not. And so now diving in, that's super important because it speaks to the core assumption, which we'll dive into now. And so as you'll see, the process using lifelines, the process to use this is very, very similar. So you import the data. I'll skip over the data prep for one moment, and then you'll see you fit the model, and then you can start validating your assumptions. And so if we scroll up, the thing I kind of just want to highlight here, I did handpick a couple of columns, mostly for illustration purposes. What you'll see is we do need to one-hot encode these variables. So for example, dependence no, dependence yes, they're now two different columns. And you'll notice that I also did drop first equals false. So the thing to note here is that, so using dependence as an example, you can't actually include both dependence no, dependence yes, because they are highly, highly correlated. And you'll actually end up throwing an error if you do it, right? Because if I'm dependence no, then you know I'm not dependence yes. And so you do need to drop one of these values for each and every column. And while you could leverage the drop first equals true, nothing wrong with that by any means. What I chose to do is actually decide what I want to drop, because that's going to get treated as the baseline. And it has nice interpretive value. And so what I did, again, totally optional, but if you look at dependence yes as an example, and we go back to the Kaplan-Meier curves, you'll see that the population, oops, sorry, there we go. You'll see that the population looks roughly like this, right? And then we scroll down to dependence, and we see that no is shaped pretty similar to what we saw for the population. And so I'm actually treating no as the baseline just because it's very representative of the population and just has nice interpretation. So scrolling back to Cox proportional hazards tab, what we'll see is I chose the model, I chose the variables, we fitted the model. And before we get into the interpretation, one extra note, you'll see I did define a 95% confidence interval. You could also do 99% if you wanted to. You can also use, similar to what you might use for logistic regression, you can use regularization. So L1, L2, elasticnet, et cetera. I didn't use it here just because of the use case, but know that it's there if you want to use it. And so now we could get into the interpretation. So what we're looking at here is we want to look at two things. We want to look at, one, are the variables statistically significant? And two, what is the interpretation? How do I interpret this and put it to use? And so the first thing we look at, very much traditional statistics, is the p above or below 0.05. We see that everything checks out, everything's statistically significant. Now we want to understand, how do I interpret this, right? How do I use these coefficients? So let's take internet service DSL. We see that the coefficient is 0.36 and the exponent to the coefficient is 1.43. So now if we scroll back up to the formula, what we see is exactly this, right? So you have your exponent, your coefficient is 1.43, or I'm sorry, your coefficient, I believe, was 0.36. And your X is basically a 1 or a 0 based on the internet DSL, yes or no. So you plug it into here, and there you go. You have a very nice, easy way to interpret this, that the change in hazard for this group, it increases by a factor of 43%, which is written here as well. And so that now allows you to start getting a very good intuition around what causes the biggest impact. And so this is just a visual representation of the same information. You'll see online backup and internet service DSL bring the biggest impact or change to the hazard ratio. We have more confidence around online backup than we do internet service because of the the confidence intervals that we see with like the long line. So with that interpretation in place, we now want to make sure, we want to answer the question, did we adhere to the proportional hazard assumption? And that goes back to this idea of right here, right? Is the hazard, that proportional hazard that we're defining for each of these variables, is it adhering to this idea of proportionality? And so we're actually going to show 3 different ways to check this. Statistical test, residuals, and a log-log plot. And so as you'll see with lifelines, checking assumptions with this, super easy. Again, I threw in 0.05. You can use other thresholds as you choose. And what you'll see is we did fail the proportional hazard assumptions many times over. And so when this happens, lifelines actually gives you a bunch of hints that you can use for course correct. I myself like to be able to look at things kind of like visually. And so that's where the idea of a residual plot comes in. And so when you look at this, you'll actually notice, you'll see 2 plots side by side that pretty much look exactly alike. It's really just how it's sorting the information, so to speak. So for now, we'll just kind of refer to the left-hand side. And so as residual plots, what you're looking for here is you want to see that there's no pattern to the residuals, right? So I don't want to see the residuals, which are represented by the blue dots. I don't want to see that the residuals are increasing or decreasing over time. I want to see them be kind of random. And if we look, and the way that would show up is that you would end up having a black bar that's pretty much straight. And as you can see here, this one's not too bad, right? There's a couple influential points we could take care of, but not too bad. But then when you scroll down, it gets pretty bad, right? So here, there's definitely a pattern that over time, we're really seeing a change. And this now goes back to, this goes back to what we were discussing earlier with the Kaplan-Meier and the lines crossing, that was actually our red flag. And we see it in, I'll scroll down to streaming TV. We actually saw this in many, many places that we crossed over. And that was our red flag right away that we were going to fail this later on when we checked it out. And if you want to dive a little bit deeper and see what's going on a little bit more of an intuitive level, you can actually look at what's referred to as a log-log plot using the Kaplan-Meier curves. And what's important to know here is that when you're doing a log-log plot, you're basically taking the log-log of the hazard ratios from the Kaplan-Meier curves, and you're plotting that against the log of the time. There's nothing magical about the application of applying log to this data. It's really just to kind of smush the range of the data so that the patterns are easier for us to observe with our eyes. And so if we scroll down, actually bouncing back a little bit again, what we want to see is nice parallel lines. And when we scroll down, what we see is not quite parallel. They're not horrible, but we do want to see actually straight and parallel is the most ideal. But we see that there is a little bit of a deviation. We actually see a little bit of this pattern where, for most of this, we see that there's this pattern where when you think about a hazard ratio, which is group 1 over group 2, we see that the hazard ratio actually is higher up, larger earlier in time, and it gets smaller as time goes on. And we see that this one's not as much, but you see it a little bit here, you see it a little bit here. And so that's why we're violating the assumption. And that's important to understand why, because that obviously lends itself to how you can kind of course correct. And once you get to kind of this in your state of the data, as is typically the case, there's a few options that you actually have at your disposal. So as is usually the case with regression, if your purpose is solely prediction, then it's actually fine that you're violating that core assumption, because what you're really most interested in is optimizing some sort of loss metric. And so in that case, you can leave the model as is. You can obviously keep tuning it a little bit, but you don't have to be as concerned. You can also stratify the model. And what that means is, let's say there's one or two variables that you know are violating the assumption. What you can do is you can stratify on that variable. So let's say tech support. We can stratify on tech support. So we'll have two models, one for tech support, yes and no. And you will, so you'll have two models. And then what you're able to do is you're able to still incorporate that model and as a variable. But what you won't get is you won't actually measure the effect on it. But that's a way to still adhere to the core assumption. Another thing you can do is you can incorporate what's referred to as a time-dependent variable. And so if we scroll back up here, what we mentioned here is that the baseline hazard is a function of time, whereas the proportional hazard is not. So what you can introduce is something that's pretty much like an interaction variable that you would use in linear regression, logistic regression, where you are basically multiplying one value times time. So you have that interaction effect. And when you do that, you actually will be violating the proportional hazard assumption, but so it's actually treated as an extension of the Cox proportional hazards. But that's another option at your disposal. You can also use cubic splines and piecewise constant hazards. And then the last one, which we're going to go into, is we're actually going to use a parametric model. In this case, it'd be Weibull accelerated failure time. And what's really, really important here is that you have a lot of different options at your disposal, and really just understanding what the pros and cons of each of them are. And so now we'll go into accelerated failure time. And the reason why I kind of wanted to incorporate this specifically was if we go back to the techniques that we're using, there's actually three classes of models when you're working with survival analysis. You have non-parametric models, which is Kaplan-Meier. What that's saying is that we're not imposing some sort of form or distribution, right? We're not saying it has to be normally distributed or it has to follow some sort of form. So that means it's super flexible. The Cox proportional hazards is referred to as a semi-parametric. And what that means is because of the baseline hazard is not parametric, whereas the proportional hazard is parametric, it's semi. And what that means is that it's a little less flexible than Kaplan-Meier, and it is imposing a little bit of a form. But the reason why Cox proportional hazard is as popular as it is it's pretty robust to it. So you can pretty much get away with using it a lot of the times without worrying too much about the functional form. But if you do feel comfortable being able to specify the functional form or the distribution of the data, that's where you would use something like a parametric model. When you use a parametric model, you have a little bit more efficiency or better power is another way to think of it. But again, with a lot of this, it's a little bit of trade-off. So it's good to know what's at your disposal. So now going into accelerated failure time. With this, the canonical example is actually if you think about dogs, right? Like it's commonly accepted that dogs age 7 times quicker than humans, right? And so that means that they're still going through all of the same life stages that we are, but they're doing so 7 times faster. And so if you think of group B as humans and the failure rate as 1/7, then your you can calculate your survival function for dogs. You can also, dogs could be group B, humans group A, you can swap them around. This doesn't have to be 1/7, it could be 7. All it's really saying is that these two groups are progressing over time, but they're progressing over time in the same way, but one is doing so faster than the other. And as you'll see with lifelines, they're very similar. They make it very easy to do. It's the same exact process. Load your data. I included some extra columns just because of where we were in the process. We fit the model. You'll see it's exactly the same. So instead of using Cox proportional fitter, we had the Weibull AFT fitter. We fit the data. And so now we can get into kind of the interpretation, which is super important. And for that, I actually included what you'll see here as mean survival time and median survival time. And so when we go to assessing the results, first we do want to check, very similar, did we adhere? Are they all statistically significant? Which they are. So now let's talk about the interpretation, right? And so if we look at online backup, we're actually flipping the interpretation. So it's the opposite of what we did for Cox proportional hazard. What we're saying is that the mean or the median survival time is going to increase by a factor of 2.08 when online backup equals yes. And that's a very, very intuitive way to interpret it, which is also kind of one of the benefits of a parametric model like this. But at the same time, I will highlight that for all of these methods, if you have the hazard ratio or the hazard, you can get the survival. And if you have the survival, you can get the hazard. So know that with all of these methods, you can kind of bounce back and forth, and using something like lifelines makes it super easy to do. So now scrolling down again, you have a very similar plot. So you could kind of just look at it visually if you would like to. You can also look at what's referred to as a partial effect plot. And what this is basically doing is, we're taking many, many variables into account. I want to just visually look at what the effect on the baseline is when this variable equals 1. And so you'll see I've kind of plotted this out. Again, we'll share the notebook so you'll have it at your disposal. And then lastly, we get down, scrolling a little bit, you can use something that's very common to use, is referred to as a calibration curve. And this is pretty neat because it actually lets you look at what are the observed probabilities versus what we predicted. And this actually kind of highlights what I was going into before about it being a parametric model where we are specifying the form that the data is going to take. And you'll see the observed is a little bit higher, then it's a little bit lower. What you would want to do kind of in practice is, let's say you're working with a bunch of these models. You can also use, there's two other parametric models I would share, is log logistic or log normal. There's also exponential and a gamma, a bunch of different at your disposal. And I think in practice, what you'd probably want to do, so if you were doing this in Databricks, you use MLflow, and you can actually log, I'll scroll back up to the metrics. You can actually log these values. So concordance, AIC, log likelihood, et cetera. And you can start now tinkering with like, what's the best formula that you should be working with. And when you're working with concordance, what you're looking for is, it's basically, are we ranking the data effectively? So the higher, the better. AIC, the lower, the better. So that covers the calibration curves. And now we've outputted a survival probability curve, right? And I'm now going to go into how you can kind of plug this into customer lifetime value. But what I do want to highlight is that, one, the output that I'm using, while it's coming from this model, it really can come from any of the models that I've shown you. And using something like lifelines, it's a common API across the board. So it holds across the board. The second thing is that I'm kind of highlighting a very specific use case, but hopefully you can see that it can get used in many, many different ways. And so in one of my kind of past experiences, I actually remember talking to a co-founder of a startup, and I was talking to them about LTV. And I had brought up the topic of LTV, and the comment was that we don't really look at LTV. We actually look at 90-day payback, because as a startup, we need to get our money back ASAP so that we can keep marketing and building our audience, because we only have so much runway. And well, I think that that's a super valuable kind of perspective. And I think within telco, you're probably not looking at 90 days. You're probably looking more like 1 year, 2 year, 3 year. But this idea of understanding, when are you going to break even So I'm going to go out and I'm going to acquire a bunch of users. When am I going to break even and recoup my marketing costs? And so that's what I'm showing here. But again, you can use this. For example, you're getting a survival probability, which you're viewing here. So at each month, what's the probability that I'm going to survive? You could use that in many, many different ways. But again, a simple example. So what you'll see here is the way I've kind of constructed this is you have the month. So every month that the person is with the contract, the probability that I'm going to survive at month 2 is 87%. Survive in this context means that I have not churned. I've plugged in a subscription value here, again, for illustration purposes. What's important to note here is this is a little bit of a simple example, right? If you have a monthly fee, that's pretty easy to take into account. If you have transactions, maybe we want to look at I'm going to change my plan, or maybe I have an overage and that's going to cost me 15 bucks a month. Like those type of events, you can actually build out another model, incorporate that. But the general flow would be very much the same. So we have that, right? So we know that, let's say we acquired 100 people, month 2, 87% of them will still be with us, and they're going to give us 30 bucks. However, because 13 of those 100 people, so again, 87%, because 13 of those people churned, the average kind of expected profit across all of those people is actually $26, right? And this works when you start really going across the population because you know what the distribution of your data is going to look like. So now we know what's the average expected monthly profit. We can now discount it. A common thing that a lot of companies use at really the time horizon is an important thing to take into account here. If you're viewing a short amount of time, it might not really need to worry about it. But if you're dealing with a large period of time, you definitely would want to include net present value. The way we're calculating net present value is it's basically 1 over 1 plus an internal rate of return. So it would be 1 plus 0.10. And then that gets raised to t, which would be here. And what this does is we're basically discounting for time. And so you'll see now, even though we're paying 30 bucks, we're getting 30 bucks from every subscriber. The fact is some people are churning. So our average profit across the board is actually decreasing for that cohort of users that we acquired. And the money we receive in month 2 is, you can consider as being worth more than the money that we're going to get down here because it's discounted for time. And then you can kind of sum this up and you can get a good view of, for example, if I need to recoup the money within 1 year to show that I've made profit within the fiscal year for my marketing ask, then this is the number I kind of need to manage against. And, in practice, I don't think these variables are necessarily what you would go market on like Facebook to, for example. But again, with a lot of this, it's the same, the concepts still hold and they're applicable. And so you can very much shape this to the contours of your business. And so that covers what I was going to go through. I think we can now toss it back to Steve.
Awesome, Dan. Thank you for covering that. We're done with the demo portion, everyone. So if you have any questions for myself, Dan, we also have a few other technical experts that are on the line with us to answer any questions that you have. Feel free to drop them into the Q&A panel. I do have one question that did come in. The question is, how frequently do you need to update the model for these use cases that you showed? And again, folks, feel free to drop any questions into the Q&A panel here.
So for that one, that actually reminds me of something I should have said at the beginning. So Brian Smith, who's on the call, actually did a survival analysis for the retail industry. And there is a blog that we posted for that. And there's actually an extensive amount of Q&As, and that specific question I actually remember being asked. Maybe we can share actually the link to that in the chat so everyone can kind of take a look, because that also has a lot of the code to kind of get started before we send this out. The answer is it depends on your business, right? If, in this type of scenario, like you probably don't need to be doing it like daily, right? It really depends on like what's your use case, how are you using the data. You probably, in many cases, you can probably get away with maybe monthly. But again, I can't actually really give you a time period because it very much depends on your business.
Cool, and we still have more time for questions here. Again, if you have any questions, definitely feel free to throw them into the Q&A panel here. Looks like we've got one here. Give me one moment. Can figure out the wonder that is Zoom.
Tell you what would help first, just to read it out to you.
That would be terrific because I can't seem to open it.
Then Daryl asks, I understand the churn analysis demo uses small data for practical reasons, but is using pandas data frames and ostensibly Python packages for survival analysis. Can this implementation scale to big data and leverage Spark? Otherwise, why not just use Jupyter on an on-prem machine?
So great example, great question. I have actually a few different answers to this. So first and foremost, what I'll say is that exactly to your point, the data set that we use here is pretty small. And if this were what you're working with in practice, then like you don't need anything. You very much could do this locally and you'd be fine. The reality is that in many times what you're going to be working with is really large log files, and you're going to need to process that data. And that's where you would really need to leverage the scale of like distributed computing. When it comes down to the modeling piece of it, that's where my answer would kind of get a little nuanced as well, right? So one thing is, it is important to know that within Spark, we do have the ability to use Panda UDFs, which you can kind of leverage in certain capacities. But also, a lot of the math behind this is actually pretty straightforward when you kind of dive into it. And so you could implement it a little bit more custom. Within Spark ML, we actually do have a accelerated failure time model. That actually ends up being, it's easier to distribute computation-wise than the Cox proportional hazard. But I also would add in that, like, I would argue that a lot of your heavy duty crunching is really going to come into shaping your data in the way that it needs to be shaped. And so you could argue that you then leverage the power of Spark to kind of create that curated data set that you want to work with. And at that point, it's probably pretty manageable that you can then leverage, whether it's lifelines or something custom.
Awesome, Dan, thank you. It looks like we are, we don't currently have any more questions. So if you do have any questions, feel free to drop them into the Q&A panel here. We're available for another 30 minutes. So would love it if you have any other questions that we can help answer. In the meantime, as we, in case you have any questions that we can answer, if you are not currently a customer and you are interested in a free trial of Databricks, you can go to this link here, databricks.com/trial, and we can make available a free trial instance for you. We have lots of folks that like to poke around and kind of try the platform out for themselves. So this is a great way to do so. And another link of interest here is databricks.com/blog. A lot of the notebooks that Dan walked through today, we post them there, but we also have, for those of you who are data engineers, data scientists, business analysts, kind of deep technical assets to help you get started for common use cases, as well as kind of best practices around optimizing Spark, MLflow, Delta Lake, and some of the components of the Databricks Unified Analytics Platform. I am not seeing any other questions. We'll give it another minute here. Oh, looks like we've got one more here. Brian, if you would be so kind to read it, because I can't seem to open the question panel.
I think this is more of a general question about feature stores, but basically this question is, where is Databricks at with regard to supporting the concept of a feature store? And Dan, you might even relate that back to the survival analysis we're doing here. how would a feature store maybe help us with performing this kind of work on that monthly basis?
So I think in that one, I think it's a great question. I think to your point about like we're kind of defining the features that we're using. I do know I would actually um, specific to feature stores. I know that that's definitely a hot topic. I would actually say I can as we kind of like send this out, I can probably put that in a Q&A with a deeper context into like where we're thinking and how you can leverage this.
Next, and we do have another question that came in regarding general use cases. Steve, you mentioned at the top of this that this is part of a general solution accelerator program. What other use cases are we looking to develop, and are we thinking about the possibility of partnering with some customers to develop those?
Yes, yes, and yes. If you are a current customer, a lot of these are built around, we'll either use sampled data from a customer and kind of partner with a customer who maybe has interest in a use case, but maybe they don't have the skills to do so. So it's kind of like a little bit of a give to get. Like we can partner together and work on building out a use case if you make available a data set. So we've done this with a few customers. It's a great way for us to help you. It's a great way for us to help other customers more broadly that are looking at this. In terms of our roadmap of use cases specific for telco, we are going to be working early next year around network analytics use cases. We have a few customers that have real-time pipelines built for PCMD, CDR, LSR analysis, and we're going to be building something around this. But if you are specifically interested in kind of building something and you want to partner around leveraging a data set together, we are ready, willing, happy to have that conversation. So, and on the next slide here, actually, if you're interested, definitely feel free to reach out to Dan and I, because this is, again, like we really want to make Databricks simple for our customers. Part of that is giving them ways to get to value quicker, which is the whole intent of this accelerator program. So we'd love to partner with you. Great question. Glad someone asked. Any other questions? We'll give another minute or two. Again, if you have any questions, feel free to drop them into the Q&A panel here. Brian, anything new in the Q&A panel?
I think just a general question, but probably worth restating about sharing the slides, sharing the notebooks, the recording for this. What's the game plan there?
Game plan is all of the notebooks that Dan walked through today, as well as the slides, will be shared with you in the next couple days. So definitely for anyone who's registered, we will send this out. And then if you are interested in the recording, just feel free to reach out to us and we're happy to send that as well. But the notebooks and deck will be sent after today. Any other questions? Okay, well, I think we are. I think at that we are. We've exhausted the questions. Again, a reminder: we'll be sending notebooks in kind of what we reviewed today. We'll be sending that after our presentation. Will be sent within the next couple days. If you have questions specifically on the notebooks, absolutely feel free to reach out to Dan. He's dan.morris@databricks.com, and more than willing to answer any of the technical questions that you have about what he reviewed today. If you're want to talk about a POC, if you want to kind of talk about your specific use cases, if you'd love to partner around some of these accelerators, please feel free to reach out to me. We'd love to have that conversation. I am at steve.sobel@databricks.com. Again, we're really thrilled that you were able to join us today. Dan, you did a fantastic job kind of walking through these notebooks and how we're helping telcos in terms of optimizing their customer lifecycle. Again, really appreciate you joining us today, and we hope that you join us for our next event. Thanks, everyone. Hope you have a terrific day.
Thank you.